next speaker is Maggie Wigness. Just give me a second. So Maggie Wigness is currently an undergraduate senior at Pacific University in Forest Grove, Oregon. She will graduate with a major in computer science and minors in mathematics and philosophy. She then plans to attend graduate school to further pursue studies in computer science. So thanks a lot, Maggie.
Hello. I was currently working with Mike Rowell and Chad Williams of Pacific University, and we've been developing new iterative methods to use fine-grained data to rank college football teams. And before I talk about our methods, I'm going to talk a little bit about the current college football ranking system, which is established by the Bowl Championship Series, or as I'll be referring to it as BCS. And the BCS rankings have been in existence since 1998, and since then have undergone a lot of reconstruction. But currently, the system is made up of 3 distinct parts. The first 2 parts are human polls, and our research doesn't look at these human polls at all. What we are concerned with is the third part that's made up of computer algorithms to generate computer rankings. And the computer algorithms have undergone a lot of reconstruction as well. Most commonly known is they're no longer allowed to use score statistics so that teams aren't encouraged to run up the score on their opponents. But a lot of common data that's used within these algorithms are the location of a game, the date of a game, strength of schedule, or how tough a team's opponents are, and the actual outcome of a game. And the BCS rankings are relatively important. One, it determines who plays in the national championship bowl game, but some conferences have also decided that in the event of a conference tie, that they can use these BCS rankings to break this tie. And as other bowl games make their selections, they could potentially use these rankings to influence those selections. And because of this importance, we started our research began with determining how accurate these rankings really were. And again, just looking at the computer rankings. And so we determined the accuracy of the computer rankings by seeing how well they could actually predict the outcome of a bowl game, assuming that the team ranked higher by the computer ranking should actually win the game. And so what this table indicates is the number of correct games predicted and incorrect games predicted since 1998. And you can see the accuracy along the bottom. What you'll notice is that the accuracy is extremely inconsistent. We have percentages from 33% to just over 70%. And if you look overall in the bottom right-hand corner, you'll see that the computer rankings sit at 56.6%. And this percentage is not statistically significant. Our p-value is almost 0.07. And this kind of led to some preliminary methods for us to try to develop some type of method that to see if we could kind of get in the similar range of what the computer rankings were getting at. And so we used a lot of the same data, the date, location, strength of schedule, and we went ahead and use the score statistic as well. And we relied on looking at the difference of scores throughout a game. And so with that, we went ahead and developed a method, and this table indicates how well our method did looking at the same games that we looked at for the computer rankings. And our consistency is still lacking a bit, but overall our percentage sits at 60%. And it doesn't seem very much more than what the BCS was currently at, but it is statistically significant. Our p-value is less than 0.01. And so we looked at this, and we determined that the score statistics really gives us kind of a high-level view of what's going on in a game. It indicates a little bit, but it really doesn't show us what's going on during the actual play. And so we tried to see what other fine-grained data we could use to look a little bit more into actually what's going on throughout the game. And this led us to using play-by-play statistics. And so when we look for statistics to use, we really look for stats that could measure some type of team success. Ideally, we'd like to find one stat that could always predict the outcome of a game. But we know this isn't going to happen. So we look for a statistic that, for the majority of the time, can correctly predict the outcome of a game. And when it doesn't, we go ahead and use that statistic to indicate the magnitude of a win or a loss. A team may lose to their opponent, but if they have a higher statistic than their opponent, then it could indicate that the game was very close. Maybe they only lost by a field goal. And so before we start running this method, I had to actually get play-by-play statistics, which took a lot more time than we had planned. I designed a web crawler that would navigate to pages on ncaa.org that contain these play-by-play stats, and I would download them, and then I wrote a parser that actually extracted that data so we could put it into a database fairly easily. And this is just an example of where we downloaded the statistics from and what I had to parse them from. And so we retrieved 3 full sets of data for the last 3 seasons, and everything else prior to that was missing quite a few games. And so we started with just looking at the 2007-2008 season, and we ran over 40 different play-by-play statistics within our method. And the table you're going to see next shows some of the statistics that we used, and you're going to see a percentage next to them. That percentage indicates the accuracy of our method when we use that statistic, and that accuracy is based on for all 32 bowl games played for that season. So again, some of the statistics that we ran, you're going to notice a few things. Some of the statistics have little asterisks next to them. We ran most of the statistics in 2 different types of scenarios. We ran the statistic throughout the entirety of a game, so when the game started till the very end. But we also ran the statistics in what we defined as a close game, or a game within 14 points. So we looked at the entire game, but we only calculated that statistic when the difference in score is 14 points. So this puts this cap on teams as well, so that teams aren't encouraged to run up these statistics or run up the score on their opponents. And in most cases, when we looked at the statistics within this close game, we actually got better results. You'll also notice that we have a variety of statistics. We have some statistics that are very general, such as defensive big plays. This measures a lot of what's going on in the field, interceptions, fumbles recovered, safeties, and sacks. But we can also get really specific with the statistics that we look at. And, for example, just look at the percentages of yards gained toward a first down, but only those plays that are rushing plays that occur in the second half. So we have a variety of statistics that we can look at. So we have 4 statistics that did the best for this 2007-2008 season, all above 65%, which is good. And we wanted to compare these directly to the BCS. Now, we can't use these percentages to look at how well they did, because we can go ahead and rank all 32 bowl games with our method. The BCS, because they only put out rankings for the top 25 teams, we can't determine if they predicted all 32 bowl games. So we can only look at games where there's at least one team ranked in the BCS top 25. So we took these statistics and we looked at just those games that we looked at, determine how well the BCS did, and we went ahead and determined how well they did with just those games. And so we can directly compare our method, given those statistics, to how the BCS did. So for 2007-2008, the BCS only correctly predicted 47.1% of the games, and all of our statistics did significantly better than what the current BCS method was doing. So this was encouraging, and because our statistics did well on an individual basis, we went ahead and started combining some of these statistics, hoping that we could yield even greater rates of accuracy.
Can you define first down versus set of down? Does that mean like percentage of time you make the first down?
Yeah, so it's every time you have a set of downs. If you do go ahead and complete it for another first down, then you did, and if you didn't, then you didn't. Yeah, but yeah, we'll just calculate the percentages of how many times you actually do hit the first down. And so we had 4 statistics that did well for 2007-2008. I started combining just 2 statistics together, and we saw good results, meaning that when we gave weights to the statistics, we yielded greater rates of accuracy. And so the results I'm going to show you are when we combine 3 different statistics. And essentially what happens is we give each statistic a weight. And so all the weights add up to 100%. And we ran all possible weight combinations in increments of 10. And instead of just looking at the one season, we ran it on all these combinations on the 3 years of data that we had access to. And we looked for weight combinations for these 3 statistics that did really well when predicting the outcome of bowl games. And so if you look at the table, all these weight combinations did really well for the 2008-2009 season. So for example, if we have 30% of the weight given to that first statistic, 20% of the weight given to the second, and 50% of the weight to the third statistic, our overall accuracy for all 32 bowl games for that season sat at 82.4%. And the rest of the table follows, again, looking at all the overall averages. So again, overall, looking at all the games, but if we want to go ahead and directly compare that to the BCS, we have to look just at those games that we used when calculating the BCS accuracy. You can see that at the bottom, that all the statistics, the weight combinations listed, had a 73% accuracy when just looking at those same games that we did for the BCS. So all these weight combinations did really well overall, but they also did significantly better than the BCS method. The problem is that there wasn't a weight combination that worked from year to year. We had really good results for each year, but nothing common between all three. So we started looking for another method of determining appropriate weight combinations for statistics. And this spurred an idea of some type of week-to-week learning, suggesting that as the season progressed, we could learn which combinations were working best. And so essentially what we did is we ran all possible weight combinations from week 1 to week 8, and we determined which weights did best when predicting the week 9. And we'd keep track of those weights. And we'd run our method from week 1 to week 9, and we'd see which weight combinations did best when predicting week 10. And once we got all the best weights week to week, we just averaged those weights to come up with final weights so we could develop overall rankings, and we could see how well those rankings could predict the outcome of a bowl game. And so I'm going to show you the results. And what this graph shows first is how each of the statistics that we combined, how they did on an individual basis. So there's no combinations here, just every year how well they did on their own. And the idea is that after we combine them with this method, week-to-week learning, that we would yield greater results than all three statistics on an individual basis. And so what this green bar shows is the accuracy of our method when we did calculate the weight combinations on our week-to-week learning system. And you'll notice that in all 3 years, the combination that we calculated does better than 2, or at least as good as 2 of the statistics individually, but never exceeds all 3. And so this was a little disheartening because we were hoping for greater results when we combined all 3 statistics. However, we went ahead and looked at what would have happened if we had picked the best weight combination. And if we had picked that best weight combination, which is what the blue bar indicates, we would have exceeded all 3 statistics on an individual basis. So there is a weight combination to combine statistics that will yield greater results than just using statistics on an individual basis. We just didn't calculate that when we did the averages week to week. And again, the graphs before showed the overall results. And if we want to go ahead and look at how our combinations directly compare to the BCS, we're going to just look at those games that we looked at when determining the BCS accuracy. And even though our week-to-week learning system didn't do as well as we had thought, it still did better than the BCS in 2 out of 3 years. So for 2007-2008, you can see that our overall accuracy was still better than what the BCS was doing. And if you look at the peak combination, which indicates the weights that would have done the best had we picked them, it never does any worse than what the BCS was doing. And you'll notice that this peak combination is very consistent, not like the BCS at all. So, with that said, we've shown that there's evidence that using play-by-play statistics can help to develop rankings that are accurate, and that when we combine those statistics, you can yield even greater rates of accuracy. But there's a lot of future work to be done. We've only shown results today regarding 3 statistics that we've combined, and we have a plethora of statistics that we still need to try to combine. And we definitely need to find a more effective method of determining the weights when we do combine these play-by-play statistics. And what kind of a project would it be if we don't run our methods as in real time as this season is continuing? So we've listed the website to where we'll be posting our rankings as this current season develops. Just like the BCS, we won't be putting out rankings until at least week 8 so we can get enough data. But yeah, so if there's any questions. Yeah.
First, thank you.
When you said third down conversions, that was not the percentage of times they were successful on third down, that was the number? Because I'm thinking that a great team would never even have a third down opportunity, and therefore would
So regarding the percentages were how well our method worked with that system.
About the definition of the variable third down conversion. How do you define it?
Yeah, it was just the percentage of the percentage of third downs that were converted into a first down.
You didn't say percentage.
Oh yeah, sorry.
Your weights, are they varying from one year to the next? Are they based on learning for that?
Yeah, so because we tried to find the weight combination that would work from year to year, but we just couldn't find one.
But the BCS is not changing from year to year, is that right? The BCS method of prediction is not changing.
I don't think so.
The prediction accuracy, is that based on only the bowl games or based on like week-to-week prediction? I'm kind of curious about the sample size.
Only the bowl games, and we did run to see how well the BCS did from week to week, and that percentage does go up if you look from week to week because, I mean, the bowl games are intended to get teams that are closely ranked to play each other a lot of the time, and so during the regular season, you'll see a lot of teams that are ranked good that will play a team that's not even ranked by the BCS. So that percentage does go up, but so our methods go up as well.
Some websites that analyze pro football found that average yards gained for pass attempt, average yards gained for rush attempt are really good predictors of success. Were those statistics in the model, and if so, how did they perform?
We ran a lot of statistics. We have some here that I'm trying to think. I know we did like yards per play. I'm not sure. We did look at a lot of rushing statistics as well. Not so many passing, but yeah.
I want to call Andy, but I guess it's got people like learning what models to use. Was you ever comparing predictions versus what the Vegas line was for goals? Just to see how they compare to Vegas?
Yeah, well, I have not done that, no. But, yeah.
Any other questions?
Really more of a comment. I mean, one of the ways in which the BCS kind of triples itself, as you said at the beginning, is the opportunity to take scores into account. And I actually think that's a good thing because it's kind of sad to see these 60-0 scores. You know,
Right.
Nebraska schedules itself against some cupcake team. But I like those asterisk statistics because it's always within 14 points, and so Nebraska doesn't gain by a 60-0 blowout. And so I think it's a good idea to, if rankings or if the bowl things were based on those kinds of statistics, you would get the best of both worlds, more accurate than the BCS, but without encouraging teams to just, stomp on their opponents.
Right.
Any last question?
One of the kind of issues with, I guess, the peak weightings is that that's kind of a 20/20 hindsight type of thing, right? Is that you could only come up with the peak weighting after you determine the result. Did you guys have any indication of why or how those things moved and how you might be able to predict what would the better weighting be based on a season or based on certain
Yeah.
occurrences in the game?
Not yet, really. This play-by-play method that we've been working on, we haven't actually looked at it for a significant amount of time, and so I think that that's definitely something that future that we'll definitely look at.
Well, let's give Maggie a hand.